All right, let's make this key real quick. So this is the interpreting position time graphs. For number 1 on the top graph, it says we want to rank the speed of the object in each of the 4 labeled regions on the graph from fastest to slowest. If the object has the same speed in 2 or more regions, indicate so in your ranking. So what I'll probably do is go through each section and actually find what the speed is. How do I do that? This is a position graph, so the slope is going to give me velocity, and I can use that to determine the speed. So the slope of this first section, the rise is 20, so not yellow. The run is 4, and the rise is 20, so the slope of this section would be 5, so that would be my velocity, 5 meters per second. The slope of section 2, it doesn't rise at all, so that slope is 0. That means our object was not moving. If I look at this section by itself, it goes from 6 to 10, so that's a run of 4, and it goes from 20 to 40, which is a rise of 20, so it also has a slope of 5 meters per second. So I see that 1 and 3 are the same, and they're greater than 2. So I'll go ahead and put those in there. So 1 is equal to 3, and both of those are greater than 2, which is 0. And let's look at section 4. It falls 20, and the run is 2 seconds. So its rise is negative 20, its run is 2, so that is a slope of negative 10 meters per second. So the velocity is negative 10, but my speed is just 10 because all that negative is telling me is that this object is moving in a different direction. But it still has a speed of 10, which is greater than sections 1 and 3, which have a slope of, or speed of 5 meters per second. So what total distance did the object travel in the first 12 seconds, including all parts of its motion? Well, let's think about that. In section 1, it went from 0 to 20. So section 1 was a distance of 20 meters. In section 2, it didn't move at all, so that was a distance of 0 meters. It moved another 20 in section 3, and then moving from 40 back to 20 is another distance of 20 meters. Again, distance, I'm not caring about whether it's moving right or left. So if I add all these distances together, the total distance traveled was 60 meters. That takes into account every section of the graph, all paths taken, and we just add up the distance. How is that different from displacement? Displacement is only caring about beginning to end. Remember our formula for displacement. Final minus initial position. What was my final position? Well, that was 20. We can see that there. My initial position was 0, so my displacement was a positive 20 meters. So what that means is, by the time it finished its motion, it ended up 20 meters away from where it started. And for us, this would be 20 meters to the right of where it started. All right, let's move on. All right, you have 3 different ants, A, B, and C, and this is how their motion is plotted. So rank these ants in order of their average speed during the 25-second interval, beginning with the fastest, indicate any equal ranking. Well, speed is distance over time. So let's find this, for all 3. So the time for it is the same. They all are traveling for 25 seconds. So what distance was traveled by each ant? Let's start at the top, work our way down. C went from 14 to what looks like, we're just going to say 18. It's a little bit blurry. We'll go with that. So from 14 to 18 is a distance of 4, and that's supposed to go on C. What about B? From negative 2 to 12 is a distance of 14, and then it stays at 12. So B travels a distance of 14 meters. And then what about A? A goes from 10 to 2, which is 8 meters, and then from 2 to 4, let's say that's 4, which is another 2 meters, so 8 plus 2 would be 10 meters. So divide these fractions and get some decimals, and this is what we get. A has a speed of 0.4, B has a speed of 0.56, C has a speed of 0.16. So, rank from fastest to slowest average speed. Well, the speed of B is greater than the speed of A, which is greater than the speed of C. Which ant obtains the highest instantaneous speed? We've been talking about average speed so far. What does instantaneous mean? It's the speed at a specific point in time during the interval. So really what we're looking for here is what ant traveled the fastest at any point in time. So I can see C traveled the same speed the entire time. So C speed was 0.16 the entire time. Let's look at B. B had a speed from 0 to 10 seconds, and then it stopped. So its speed in this section was 0. What was its speed in this first section for B? Well, this first section, the rise was 14, the run was 10, so this first section had a speed of 1.4 meters per second. Let's change colors and look at A. A had a certain speed in this interval, and then it changed and was moving in the opposite direction. It had a speed in that interval. So let's find those speeds. The first section, from 10 to 2, that's a rise of negative 8 over 15, which is, if I do that real quick, this would be a slope of negative 0.53. Again, that's velocity. To get the speed, I would just say it's 0.53, because the negative just indicates direction. In the next section, it rises 2 from 15 to 25, which is 10 seconds, so that would be a slope of positive 0.2 meters per second. So if I want to know which one was traveling the fastest at any point in time, I can clearly see that this was the fastest speed attained by any of them, and so my answer for this would be ant B. It had the highest instantaneous speed at any point in time. We're not looking at the whole interval, we're looking at specific sections, which one had the highest speed. I could also tell this without actually calculating the slopes at all. I could tell that by noticing that this line is the steepest line of them all. Steepness means speed, or steepness describes speed in a graph. So the steeper the line, the faster that object is going. All right, last one. Calculate ant A's average velocity for the time interval. So remember, average velocity is displacement over time. So the time interval is 25 seconds. What was ant A's displacement from beginning to end? Well, it starts at 10. It ends, we're saying, at 4. So if I do final minus initial, it ended at 4, it started at 10. Displacement was negative 6 meters. So if we put that in the calculator, we get that average velocity is negative 0.24 meters per second. So, on average, ant A was mostly moving to the left. And I can see that there was a longer interval here where it was moving to the left, and there was a shorter interval where it was moving to the right. But overall, it ended up to the left of where it was to start with. All right, so now let's talk about the flagpole matching activity. So consider a frame of reference attached to the flagpole shown. Positions to the right are considered positive, so that means positions to the left are considered negative. So what does that mean for my diagram? If I'm looking at the flagpole up here, that means I'm taking the flagpole to be 0. That means if I'm talking about meters, then this would be 5 meters, this would be 10, this would be negative 5 meters, and this would be negative 10 meters. So, but the numbers really don't matter for us, for this one specifically. We're just trying to match it to the correct description of motion and an equation that could possibly go with this graph. So let's look at object A. Object A, it starts at a positive position. So it should start at a positive position, which is to the right of the flagpole. So if I'm looking for a description, if it says initially to the left, I know that description is not right. So it is starting to the right, and which way is it moving? Well, this graph is sloped upward, so it must be moving in a positive direction to the right. So it starts to the right, and it also moves to the right. So that looks like word description T. So I'll put T there for the word description, and I'll mark that out as being used. What about B? It starts negative, so that means it starts somewhere over here in the negative region. So it starts to the left. And let's look at this graph. It is sloped downward, so it moves in a negative direction, which for us is to the left. So it starts left, and it also moves left. So which one is that one? That looks like V. The object is initially to the left and moving to the left. So we'll scratch that out. We'll put that there. What about C? It's sloped upward, so it's moving right, but where does it start? Well, it starts at 0, so it starts at the flagpole. So it's initially at the flagpole, and it should be moving to the right, which looks like word description U. All right, object D. It starts to the right of the flagpole. What's the slope of this flat line here? Well, the slope is 0. So that means if it starts to the right of the flagpole, it's going to stay at that position and not move. So if it starts to the right and it doesn't move, which description is that? It looks like S. Standing still to the right of the flagpole. What about object E? It's a flat horizontal line, so it's not moving, but where is it? It's at 0, and it stays at 0, so it is at the flagpole and staying there. So that looks like word description X. All right, object F starts negative, so it's starting negative, so it's starting over here, maybe at -10, but it's sloped upward, so it's moving in a positive direction. If it's sloping upward, it is moving to the right, so it starts to the left of the flagpole, and it's moving to the right, which is word description R. And don't worry, I'll erase all these scratch outs in a second so we can get the key in its fullness. Object G starts at 0, starts at the flagpole. The line is sloped downward, so it should be moving left. That looks like word description W. Object is initially at the flagpole, moving to the left. So now we got 2 more. X starts in a negative position, starts to the left, and it's a flat line, so it doesn't move. So the object is standing still to the left of the flagpole, which is Z. And then lastly, we have Y, which says the object is initially to the right and is moving to the left. So it starts positive, so that makes sense. Slope downward means moving to the left, so that makes sense as well. All right, so let me erase these. What about our equations? We haven't really talked about fitting equations to graphs yet, besides the first pivot lab we did. So let's look at this. We just have to understand what an equation of a line is telling us. So all these lines are going to be in the form y equals mx plus b, where b is our y-intercept, and m is our slope. So remember, this means positive slope if I'm sloped upward. This means my slope will be negative. If it starts above, that's a positive y-intercept, If it starts below, that's a negative y-intercept. So let's look at object A. It's sloping upward, so I should get a positive slope, and it is also starting above the x-axis. So my y-intercept should also be positive. So M and B should both be positive. That's equation 4. What about object B? Sloping downward, so my slope should be negative, and it's also starting below the x-axis, so my y-intercept should be negative. That is equation 7. Object C starts at 0, so there's no y-intercept. Starts at 0, but it slopes upward, so my slope should be positive. That's equation 8. Object D, the slope is 0, so I shouldn't have any mx term, which in this case is t, and y is our x, based on our graphs. So for x, it should just be a number, like x equals this, and that number should be positive. That's equation 10. Object E is at 0, stays at 0. That's equation 12. Object F starts below 0, so my y-intercept should be negative, but it slopes upward, so my slope should be positive. That's equation 5. Object G starts at 0, but it has a negative slope, so that is equation 9. Object H starts below the x-axis, does not have a slope, the slope is 0, so that is equation 11. And then finally, equation Y, negative slope means I'm going to have a negative m value, and I have a positive y-intercept because it starts above the x-axis. That would be equation 6. So there's the key. Hopefully this makes sense, how we're matching these equations to the graphs and also word descriptions, and really thinking about how do these graphs show us what's happening in relation to this diagram, this physical situation.